everyone, I am Guo-Chang Wei. Today, we'll talk about OTN to CO, the video-centric best experience bearer network solution. There are three aspects to cover. According to relevant statistics and predictions, video traffic accounted for 70% of all network traffic in 2016 and will account for over 80% by 2021. Videos drive the network traffic to grow rapidly, with a compound annual growth rate of 24%. Traffic from 4K videos will grow from 1% to 17% of all network traffic, with the compound annual growth rate reaching 106%. We can conclude that videos form the major part of network traffic. UHD videos develop rapidly, and 4K videos have the highest growth rate. As UHD videos develop, the requirements on networks become higher. 4K videos require 30 M bandwidth per screen and 20 millisecond E2E bandwidth. In addition, videos change the way people use networks, which in turn has a huge impact on network design concepts. In the web era, in which people mainly browsed websites for texts, pictures, and music, the bandwidth was not used continuously. No more traffic occurs after a web page is downloaded, meaning that the concurrency is low. People can tolerate it when a web page takes a few seconds to load. In other words, people don't have high requirements on acquiring information in real time. In such scenarios, network bandwidth can be multiplexed efficiently. Bearer networks with a high convergence ratio are designed to reduce costs. User experience can be affected by congestion, packet loss, or high latency, but this is tolerable. However, the situation is different with videos. First, when people watch videos, data is transmitted continuously, meaning that concurrency is high. Hotspot videos will cause 30% or even more burst traffic. Second, people are tending to watch videos anytime, anywhere, bringing rapid growth in mobile traffic, with the compound annual growth rate reaching 46%. Third, people value video experience. Video buffering or frame freezes caused by high packet loss rate or high latency are very sensible and usually not tolerated. High traffic, high concurrency, and high sensibility of video services bring challenges to traditional network architectures, but also drive global operators to move WDM downwards and simplify networks. Now, we'll analyze the challenges traditional networks face and the values of simplified networks. First, in terms of bandwidth, single fiber capacity on traditional networks is only 10G. There are two ways to expand the capacity on traditional architecture to satisfy requirements of video development. The first way is by upgrading from 10G to 100G, which requires device replacement and service interruptions. This solution also requires more investment in fiber and ports for overlap capacity expansion on 10G rings, and uses up more fiber, ports, and equipment room space. The second way is to simplify networks with WDM move downwards. The single fiber capacity can reach 8T and is fully able to satisfy development of 4K and other video services. Second, in terms of experience, on the traditional network architecture, multiple layers are highly convergent, and services are forwarded hop by hop. Congestion could occur on every node, causing high packet loss rate, high latency, and instability. As a result, frame freezes and artifacts occur frequently, and video watching experience is poor. Simplified networks reduce layers and change from ring to tree topology for IP sharing, achieving one-hop connection. OTN hard pipes ensure no congestion, zero packet loss, and low latency. As a result, users can enjoy the optimal video watching experience without artifacts or distortion. Third, in terms of cost, traditional networks use the shared bandwidth architecture, which can fully take advantage of multiplexing and reduce costs in the web era. However, the large bandwidth and high concurrency requirements of video services makes multiplexing a disadvantage. Also, forwarding costs are high because a large amount of pass-through traffic wastes network investments. For example, a ring network with 4 sites has 75% pass-through traffic. What's more, The expansion costs are high. When single-site bandwidth is insufficient, the whole network needs capacity expansion, which is completed site by site over a long period. The CAPEX and OPEX are both high. In addition, traditional networks face frequent capacity expansion challenges. Simplified networks feature a flattened architecture, optical layer pass-through, and exclusive site bandwidth, which achieve the following results. Forwarding at no costs. With optical layer pass-through, intermediate service forwarding boards are not required, ensuring that 100% investment is used on local traffic. Capacity expansion at low costs. Large capacity WDM site can be deployed at once without the need for frequent expansions. Sites are decoupled so that network-wide expansion is no longer needed. In addition, expansion only occurs at source and sync sites, which enable a quick response to capacity expansion requirements. Finally, in terms of planning and O&M, traffic paths on traditional networks are uncertain, unknown, and uncontrollable, making it difficult to precisely locate network bottlenecks during capacity expansion planning and design. In addition, multiple network layers and protocols cause E2E fault locating to be time-consuming. Simplified network traffic paths are specifically known, facilitating capacity expansion planning. What's more, reduced layers and clear interfaces enable fast E2E fault locating. Now let's give a summary. High traffic, high concurrency, and high sensibility of video services require networks with large capacity, low convergence ratio, zero packet loss, and low latency. Simplified networks use OTN to CO to reduce network layers and build large capacity, high quality, and low latency bearer networks for optimal experience. How do operators further strengthen their advantages in differentiated video experience? As we know, live broadcasting accounts for 80% of video watching, making it the goldmine for operators' revenue growth. Live broadcasting has higher requirements for better experience and is also different from OTT videos. Live broadcasting has a constant bit stream, fixed path, and high user experience expectation, requiring no packet loss, no latency, and jitter, no multiplexing, and no complex routing protocols. For live broadcasting services, the following solutions are available. 1. The unicast solution, which has traffic proportional to the number of users, linear cost growth, and experience that does not differ from OTT videos. 2. The traditional multicast solution uses shared pipes between live broadcasting and OTT videos. However, congestion and packet loss cannot be totally avoided, and the experience does not differ from OTT videos. 3. The OTN-based solution, which physically isolates live broadcasting and OTT videos. E2E hard pipes ensure zero packet loss, achieving differentiated optimal live broadcasting experience. In this course, we talked about the video-centric best experience bearer network solution. Finally, let's summarize once more. In the video era, the simplified network is a basic solution for optimal user experience. OTN for live broadcasting transport is the solution for differentiated live broadcasting experience. Meanwhile, using MS-OTN to CO for simplified networks have more benefits. MS-OTN support unified scheduling and hybrid transmission of SDH, PKT, and OTN, and unified transport of multiple services, including FBB, MBB, and private lines, maximizing network values. In addition, ASONG automatic recovery improves network reliability. That's all for today. Thanks, everybody.